Hello. So we're going to discuss a few questions on Mechanics of Material, Chapter 10, Strain Transformation. Example 1. For an element with plane strains as shown, determine A. Strains for an element at the same point oriented 15 degrees counterclockwise from the original point. We are given this diagram and we are given with three values. The normal strain along x direction, negative 0.4 times 10 to the power of negative 9. The normal strain along y direction, 0.6 times 10 to the power of negative 9, and also the shear strain of x and y, 0.3 times 10 to the power of negative 9. So the solution of A is, we substitute all values into this equation. So we substitute all the values and then we will get negative 0.258 times 10 to the power of negative 9, and this is the new normal strain in x direction. And then we know that the sum of two normal strains stays the same, so we use this formula to calculate the new normal strain in y direction. So we just substitute the value and we get this, and this is the new normal strain in y direction, which is 0.58 times 10 to the power of negative 9. And then to calculate the shear strain, we use this formula. So just like usual, we substitute all the value into this formula and we get the new shear strain, which is 0.76 times 10 to the power of negative 9. Moving on to the next question, determine the principal strains as well as the orientation. To solve this, we use this equation. So what we do is we substitute all the value into this formula and we get two principal strains, the maximum and the minimum. The maximum is the positive value and the minimum the negative value. When principal strain occur, the shear strain associated is 0, so we get 0. So to find the angle, we use this formula. As usual, substitute all the values into this formula and we get the angle, which is negative 8.35. Then, to find the new normal strain along x direction, we use the general formula and substitute all the value and we get the new normal strain along x direction, which is negative 0.422 times 10 to the power of negative 9.
Next example, the state of strain at a point on a wrench has components normal strain along x direction, which 120 times 10 power of negative 6, normal strain along y direction, which is negative 180 times 10 power of negative 6, and shear strain of x and y, which is 150 times 10 power of negative 6. By using strain transformation equations, determine the in-plane principal strains. To find the principal strain, we use this formula. Just substitute the value from the question into the formula and calculate it. For the answer which is positive, it means the maximum principal strains, and for negative, it is minimum principal strains. Then we find the angle by using this equation. Like usually, substitute the value from the question into the equation and we will get the answer, which is 13.3 degree. Move on to the next question. The question asks to find the maximum in-plane shear strain and average normal strain. To find the maximum in-plane shear strain, we use this formula we get from the books and just substitute the value from the question into the formula. We will get the answer, which is 335 times 10 power of negative 6. Then, to find the average normal strain, we use this formula also from the book. Just substitute like usually from the question, value from the question, and we get the answer, which is negative 30 times 10 power of negative 6. Finally, to complete the answer, we find the angle by using this formula. And like usually, you substitute the value from question into the formula and you will get the answer, which is negative 31.7 degree.
Okay, next example is the state of strain at point has components of normal strain along x direction, normal which is 180 times 10 to the power of negative 6, normal strain at y direction which is negative 120 times 10 to the power of negative 6, and also shear strain of x and y which is negative 100 times 10 to the power of negative 6. Use the strain transformation equations to determine A, which is the in-plane principal strain. The in-plane principal strain, by looking at the keyword in-plane principal strain, we must use this equation to get the normal strain at 1 and 2. Just substitute the value and we get E1, which is the positive, which states the maximum normal strain, and E2 negative, which states the minimum normal strain. To complete the answer, we must find the angle for the shear strain, for the normal strain, sorry. Okay, by using this formula, substitute the value given from the question and you will get the angle, which is negative 9.22. Okay, moving on to the next question. The question asks for the maximum in-plane shear strain and average normal strain. In each case, specify the orientation of the element with the xy plane. It asks for the shear strain and the average normal strain. To find the shear strain, maximum in-plane shear strain, we use this formula given. From this formula, you can just substitute the value given and we get the maximum in-plane, which is 316 times 10 to the power of negative 6. To complete the answer, as usual, you need to find the angle. By using this formula, you just substitute the value and you get the answer, which is the angle is 35.78 degrees. To get the average normal strain, you just need to use this equation, which is normal strain along x direction plus normal strain along y direction, just divide by 2. And then you will get the answer, which is 3 times 10 to the power of negative 5.
Okay, now we are moving on to the example number 4. The question has already given the normal strain along x direction and the normal strain along y direction and the shear strain. The question asks the principal strains and the maximum in plane shear strain and the associated average normal strain. So first, you can find the angle through this formula and then just substitute the information given into this formula and you'll get the answer. And then for the next step is to find the normal strain, and you can just substitute the given info into this equation, and then you can just directly get the answer. For the maximum in plane shear strain, it's just the same step with the first question. You can refer the formula from the book, the 9th edition Hibbeler book, and substitute the given information into the equation and you get the answer directly. And then the next step is to find the maximum in plane shear strain. You can just substitute the information given and just get directly the answers. And also the average normal strain is normal strain along x direction plus normal strain along y direction over 2, and you get the answers directly.